Hi, Emily. Thanks for your questions. I've got a picture of the questions that you've asked about here, so I'm just going to go through them with you briefly. I'll just make this a little bit bigger so we can look at this one first, okay? So with this one, you're given the probability of starting the car and the probability of the neighbor's car starting. And so you need to find the probability of neither car starting, okay? So what they're asking you to do there is if you have a 50% chance of your car starting, then the chance of it not starting, let's use P and S for that, is also 50%. And then for your neighbor's car also, the probability of your neighbor's car not starting is going to be 20% because he has an 80% chance of it starting. So the probability that neither start is 50%, and which in probability is times 20%, and that will lead you to the correct probability for that. Now the probability that both cars will start is the probability of your car starting and the probability of your neighbor's car starting, so just multiply those probabilities together. The probability that both cars start or neither car starts. So we have an or there, and an or means and when you're doing probability. We've already worked out the probability that both cars will start from B, so we're going to take the probability that we found in B, and we're going to add that to the probability that we found in A, which was that of neither car starting. Now, since both of those things can't happen at the same time, we don't have to subtract the intersection of those two things. It can't be that both cars start and neither car will start, so we don't need to subtract the probability of that in this particular case. For the last one, exactly one of the cars will start. You want the probability of your car starting, and if only one can start, then that means that the and in this case is the probability that the neighbor's car does not start, or, which means plus, you want the probability that your car does not start, but the neighbor's car does. And so if you add those together, then you will get the probability that we're looking for. So if we have a look at part D, number 1, I'll get you started on that, or I may have just done D. I might have done them in the wrong order. Nope, that's part D, number 1. Okay. I'll get you started on this one now. Okay. So for this one, the probability, okay, so what we're doing is flipping a coin 3 times. And so the first thing you want to do is you want to write out all of the outcomes that are possible. There are 8, and I'm not going to write them all out for you. I'll just get you started. Here's the first 2. And those are the cases where you have either all tails or all heads. There's 8 possibilities, like tails, head, tails, and so on. If you write them out, then a success is defined as landing on tails. So the probability of a success on the second flip means that we're looking at all of these outcomes now. We're looking for the middle letter to be a T. So you just want to write how many that is out of the total, and that's your probability. The probability of successes on the first 3 flips would be that you need to get tails, tails, and tails, and so you need to count up how many of the outcomes are tails for all 3 flips. And for part C, what is the probability that there will be exactly 3 successes in the experiment? That's really the same thing as all tails, and so that will be the same probability as part B in this case.